x plus 2 equals 0, or x plus 5 equals 0. The zero product rule for algebra doesn't say they both have to be 0. It just says that one of them has to be 0. Because if one of them isn't 0, you can't find two numbers and multiply them together and have it be 0 unless one of the numbers is 0. In other words, 1/4 times 4 is 1. Negative 1/4 times anything is a number. The only thing that's 0 is you have to have one of the multipliers be 0. So that's what allows me to make these two statements down here. If x plus 2 times x plus 5 is equal to 0, then I can categorically say that either x plus 2 is equal to 0 or x plus 5 is equal to 0. Well, if I solve both of those equations, what do I get for x?
X equals -2 or x equals -5.
And you'll find that both of them work.
Okay.
Okay? Now, you will, at some point, come upon equations where when you come up with two solutions, one of them is called extraneous, meaning it doesn't work. And that's okay. I remember I spent 10 years of my math career trying to figure out how you could have an extraneous solution. How is that possible? Well, it's because the theorem says that only one of these has to be 0. It doesn't require that both be 0. When you're solving a typical quadratic, you end up almost always with two solutions, and they're both valid. Okay? Let's do another one. You can just never get too much practice.
Okay.
On factoring quadratics. So start with x and x. What's the next step?
The next step is to determine the signs.
Okay, what are they going to be here?
Here there would be subtraction symbols, right?
They'd both be negative, right? I didn't quite hear what you said.
Yeah.
They have to be the same, because only the same sign, when multiplied together again, would give you a plus sign. And they have to be negative, because the middle term is negative. So they both have to be negative. Now we're looking for, what's the third step?
The factors of the variable, right?
Factors of 10 that do what?
Add up to 7.
Exactly. Again, that's 2 and 5. In other words, it's very similar to the last quadratic, it's just the sign in the middle was different. Now our answers are going to be x equal 2 or x equal 5.
All right.
Make it slightly harder. Actually, as long as the coefficient of the x squared term is 1, then none of these are hard. They're all easy, and they're all 4-step solutions, exactly doing these 4 steps that I'm teaching you. It'll get harder, in which case that's where they tend to pull in the California method and the diamond method, because as it gets harder, these problems become kind of trial and error. You have to kind of experiment with different solutions to see whether it's factoring correctly or not. But let's do this one. Step 2.
So, the step 2 would be to determine the signs.
What are they?
They'd be negative signs, right?
They're opposite.
Okay, so positive.
One's positive, one's negative. When I say determine the signs, I mean both of them. In other words, step 2 is always to determine both signs. not just 1 over here. Okay? So the fact that I have a negative sign there means my signs have to be opposite. And I could put the minus sign over here and the plus sign here, but there's no difference. So I'll put it like this. So I'm done step 2. Now what's step 3?
So step 3 is to determine the factors of 20 that will add up to 1?
Not add.
Subtract.
Exactly. When that's a negative sign, these factors have to subtract to the coefficient of the middle term. When it's a plus sign, they have to add. When it's a minus sign, they have to subtract. So I want factors of 20 that subtract to what number?
Okay, 5 and 4 subtracting to 10.
Subtract to 1. In other words, the coefficient here is 1.
Sorry.
Okay? So you were right. 5 and 4 subtract to 1. And that's what I'm looking for. So where's the 5 go? Where's the 4 go? Always put the bigger factor. This is step 4. The bigger factor goes with the sign of the middle term. So 5 is the bigger factor. It's got to go there, which leaves the 4 to go there.
Okay.
Okay? And there's one final step that I like a lot, and that's because whenever you're factoring, you're trying to make the middle term come out right. The way I designed this, I know I got an x squared and I got a minus 20. I don't even have to check those two terms. But the middle term is always a little iffy. In order to check the middle term, I merely have to multiply the inside terms together and the outside terms together, add them up, and see if I get the middle term.
Okay.
And I do. I call it my double smiley face method, because I'm always drawing these two smiley faces as my last step to make sure I got the middle term correct.
Okay.
Okay? So far, so good. I'll give you some easy ones before we'll do one hard one before I go, or before our session ends. Let's do some more easy ones.
Okay, so first up obviously is to put the x's in the correct places. And then you find factors of 20.
No, don't skip step 2.
Oh, sorry. Then you determine the sign, and it would be positive this time, right?
They're both the same, but they're not both positive. In other words, this tells you that they're both the same.
Okay.
And this tells you they're both negative. So we have to look at two things. Once we determine they're both the same, now we can figure out whether they're both plus or both minus by looking at the sign on the middle term.
Okay.
Now what's step 3?
Step 3 is now to find two factors of 100 that add up to 20.
Okay, what are those?
10 and 10.
Good. So x equal 10 is an answer. Okay, that's easy factoring in a nutshell. Now let me give you a hard one. Now, let's just for a moment talk about another easy one. Try to do this one. Now I'll even put a number in there. Here, let me write it properly. Well, x and x, right?
Yeah.
Signs both negative.
Yeah.
Now,
And then,
are there factors of 4 that add up to the number 2?
no.
No, there aren't. So this isn't going to factor nicely. In other words, there are no integers, whole numbers that I can put in there that work here.
Okay.
This is where you have to use the quadratic formula. You've had the quadratic formula? I mean, this isn't totally new to you?
This is new.
This is new. Okay. Well, we won't have time to go into this, and I won't talk too much about it, but A, B, and C are the coefficients of this quadratic. In other words, A equals 1, B equals minus 2, and C equals plus 4. So whenever you have a quadratic in standard form, which is ax squared plus bx plus c, you can always solve it using the quadratic formula. In other words, if I wanted to solve that particular quadratic, it would be minus b is 2 plus or minus the square root of 4 minus 4 times 1 times 4, all divided by 2. So there is my answer, believe it or not, to solving that particular quadratic. Now, I can reduce it, and this does bring into play imaginary numbers. I purposefully did that, but it wouldn't have to. In other words, you could still come up with real solutions that aren't integers, that would require you to have to use this quadratic formula to solve that quadratic. If that's equal to 0, then the only way I can do it is by using the quadratic. Well, there's a couple other ways, but you haven't learned them yet. But the most direct way is to use the quadratic formula. That's if it can't be factored nicely. You're not going to get to the quadratic formula for quite a while. You're going to deal with quadratics that can be factored. Okay? So, before we go, I'm going to give one more. Only this time it's not going to have a coefficient of 1 in the middle.
Okay, so
we're still going to factor it into 2 linear factors. What goes here? What goes here?
x, right? Or would it be 2x?
There you go. You always split up the x, and you make the numbers whatever they have to be, so that this multiplied back by that gives you 2x squared. Okay? You with me?
All right.
Step 2. What are the signs going to be?
They're going to be opposite and
right, but
subtraction.
in this case, that is different than this. So I have to allow for both. In other words, the moment I make this coefficient something other than 1, now I have a hard problem to factor. In other words, all those simple rules that I gave you, factors of the constant that add or subtract to the middle number, all of those go out the window now. Now you kind of have to do trial and error. But we've got most of it done, right? In other words, I know what my signs are. They have to be opposite. I'm not sure if the plus goes over here or the minus yet, but I'm going to allow for both. So what's my third step? Factors of what?
Your third step is to find factors of, that would be, sorry, 1 second, my computer's being weird.
1 and 1.
Yeah.
In other words, the third step is to find factors of 1. I can't say that they have to subtract or add or anything yet. I just need two numbers that multiply to 1. Well, that's 1 and 1. So there's not a whole lot of choices here. Either I got a 1 there and a 1 there, or I got a 1 down here and a 1 here. Well, if I try this solution and I check my middle term, I got a plus 2x, I got a minus x. That gives me plus x as a middle term. That's not right. I need a minus x as a middle term. Aha, let's move that 1 down. In other words, let's make that our solution. And notice now when I multiply the two middle terms, the inside terms, I get minus 2x. The outside terms give me plus x, and that gives me a minus x for my middle term, which is what I'm looking for. That's correct. Therefore, that's the correct factors. Okay? Now what's the answer?
So the answer would be x.
X minus 1 equals 0, which means x would be equal to 1.
Or 2x plus 1 equals 0.
Which means x would be equal to minus 1/2.
Yeah.
And those are your two solutions. So this is extra degree of difficulty because of that. But that's the only thing that makes factoring hard, is when you have a number here other than 1. And then factoring can be a challenge. But it comes down to a lot of trial and error. But they won't give you real hard problems. They're never going to give you a problem like this, because there's too many factors. There's too many ways to break it up. In other words, if I had a situation like this, well, this could actually be 4x and 3x, or it could be 6x and 2x, and then 12 has all kinds of factors also. So they're not going to give you real difficult problems, but they will eventually give you quadratics that have a number in front of the x squared.
Okay.
All right, but that's a good first lesson on factoring. Just don't forget step 2. Always got to figure out the signs as step 2.
All right.
Okay, all right, David. I will talk to you next Tuesday, I guess. You guys have school, what, Monday, Tuesday, and Wednesday next week?
We don't have school at all, and actually, we'll be gone. We're going to Massachusetts.
Okay. All right. Let me make a note that you and your sister don't have an appointment next week.
Okie dokie.
All right. Well, I will talk to you then in 2 weeks.
Okay.
All right?
Thank you.
All right. You're welcome. Bye-bye.
Bye.